Hello and welcome to another Otter Workshop video. Today we'll be looking at something not quite woody, not quite metal, not quite tool, but it's still quite cool. I'm talking about something as simple as a bath bomb. So for me, when I've been standing up quite a long time during the day, either teaching or wood turning or just in general, it is quite nice to have a good soothing bath for your feet. Now, this can be achieved in a variety of ways, but one of them is to make a foot bath. And you can do this by using a bath bomb. Now, a bath bomb is a quite entertaining and soothing spark of chemistry. It is, as many bombs are, a release of a lot of different energy and gases, as I'll show later. The manufacturing, or crafting, if you like, is very simple and could easily fit into the Minecraft crafting table, which, yeah, most people know anyway now. First, I'll explain how we make one, and I'll show you on screen me making it while I'm talking to you now. Then I'll tell you why it works, and we'll take it from there. So the first thing you'll need when making a bath bombs is mixing your different ingredients. These are sodium hydrogen carbonate, it is citric acid, it is some starch, and some magnesium sulfate, often in the English speaking world and prevalently now here in Denmark as well, called Epsom salt, but it's magnesium sulfate. It's called Epsom salt due to historical reasons of it being manufactured in a place called Epsom. And because of that, it is the salt from Epsom. That's how it goes sometimes with history. So the solids will be mixed, and after that, we'll slowly add our liquids. The liquids in this case consist of olive oil and tiny bit of water and a tiny bit of lavender oil. The lavender oil, the few drops are just there for the scent. It's not added for any perceived notions of health. They're just there to create a nice scented atmosphere, which will calm the brain. That's about it. It's just calming the senses. No mumbo jumbo or magic. It is important and imperative that the amount of water added is very slight. It is just a tiny bit needed for it to help with the solidification process. And when you have them solid, they need to stand in their shapes, and then we'll remove them, and the water will have evaporated. There is a quite telltale sign if you've added too much water. It will either all of it just fizz out in the bowl, or the shapes will rise in your molds and cause your bath bombs to be less efficient. They'll still work, but just a tiny bit less efficient. I normally leave my bath bombs for 24 hours or 48 hours. This is just to ensure that all the water has evaporated and that you can now remove them. Sometimes it is better just to say 24 hours and get them out. If you leave them for too long, too much will evaporate and they won't stay solid anymore when you press them out of your mold. In general, molds that you need to push are not that good. It should be an open, easy flexing mold. I like to use silicone molds for this exact reason. The bath bomb is quite fun when you use it, and I have some videos here to show the actual uses of them. So enjoy the little explosion, and in a moment you'll hear all about the chemistry behind. So let's take a look at what actually happens when we dump our bath bomb into the water. Initially, we will have a reaction between the sodium hydrogen carbonate with water, but the actual reaction that we're gonna see is between sodium hydrogen carbonate and citric acid. The first reaction with water is a simple reaction, and then the following reaction that it facilitates is the one with the citric acid. So we plump it in, a tiny bit of the outer shell starts reacting with the water, and you get a little bit of a fizz. And then when you have some citric acid dissolved, you'll get this more violent reaction. And this more violent reaction is the citric acid that reacts with the sodium and hydrogen carbonate, releasing some extra water and some CO2, and deprotonating, so that is removing the hydrogens from the citric acid groups. So it's gonna look like this. The main reaction that we're focused on is the reaction of our sodium hydrogen carbonate along with citric acid. So that's C6H8O7, which in turn becomes 3Na plus some C6H5O7. See, now we have lost our 3 hydrogens, and 3H2O, H2O, and some CO2. As a gas. And you'll see this little fizzing, and you will have some of the CO2 bubbling off. However, there are several components of this which actually make this into a nice bath for your feet, or just in general, a little bath. There are no soap components being formed. We have no ester bonds or fatty acids and so on being formed. We of course have the olive oil, but sodium hydrogen carbonate is not a strong enough base to separate these bonds. I'm gonna show in another video the saponification, which is the manufacture of soap, and sodium hydrogen carbonate is just not strong enough. We will get something akin to a soapy kind of thing, which is I will get a soapy kind of feel, but it won't lather like a soap and it won't be a real soap, but we will have the chelation effect of the citric acid, the deprotonated citric acid, which we will see where it can actually bind or chelate to calcium ions, which are very much present in water from Denmark. So the water will feel and be softer. You'll have some of these larger ions taken out of the equation. So I mentioned some reaction with CO2. So CO2, a lot of it will just go fizzling out, but some of it will react with all the water present, and there is a lot of water present when you're making a foot bath, which will give us some carbonic acid, which is also what you find in your soda and your beer, other things. Carbonic acid is nice as a temperature regulator as well. So when you make your nice cozy foot bath, it is warm. Hopefully, or if you like it cold, it's going to be cold. But for most people, it's going to be warm. So you dump your bath bomb down, you release a lot of CO2 and other nice things, and you get some carbonic acid, and the carbonic acid helps retain the temperature. So your foot bath will stay warm longer and you can enjoy it for a longer time. Anyone who's ever tried taking a normal bath or a normal foot bath with no additives, no, it'll go cold quite fast. It's just the nature of water and nature of most things. So it helps to make an insulating layer. But when we have an insulating layer and we have this as a thing, our feet will wrinkle. Why, yes, they will. Except if you use what is so commonly mentioned several times, the Epsom salt, or good old magnesium sulfate. Now, magnesium sulfate will, when introduced to water, of course, part into ions. Let's just do it the cheaty way. And these ions in the water will help, especially the magnesium, will help our feet not to get this wrinkly grandmother kind of texture. And that's one of the main reasons why it's there. It also helps with the softness of the water, just like our citric acid with the chelation does. So in that part, it has a nice synergy with the CO2. So we have heat retention combined with magnesium sulfate, which ensures our feet are not gonna go all wrinkly with us when we have our feet there for half an hour plus. And we have the oil, in our case, the olive oil, which will give us a nice fatty coating afterwards to moisturize our feet or hands or whatever you want to put in a foot bath or a bath in general. So the last thing I'm going to show you, the last bit of chemistry here, is the chelation. So citric acid has a nice, actually really nice structure. It has 3 acid groups. It also means it can combine with 3 different ions, which it'll do. In our case, when we have our 3 sodiums, it'll take these sodiums and make ions with it, or ion bonding with it, chelation-like bonding. I'll just show them here. We'll get these effects here. But the real kicker, and it, especially for a country like Denmark where I live, our water is hard and we have so much calcium in the water that it is nice to have citric acid to share in the fun. With citric acid will share in the fun with us and will help keep the water nice and soft. I'll see if I can fit all this in here. Yeah, so that's sodium along with the acid group here. So that's essentially what we'll have. So all these parts in conjunction will help us have a nice foot bath and keep us cozy. It'll keep the water soft. It'll keep the water warm for longer. It'll help our feet not wrinkling. And it'll just in general create some muscle relaxation. There are no mumbo jumbo healing powers. There is no crazy osmosis of magnesium ions. Body doesn't work like that. This is in general just a nice calming feeling, and that's all it should be taken for. It's no different kind of magic like that. Right. So with that, I hope you have had a nice time watching the creation of the bath bombs, and I hope you enjoy the little explanation of the chemistry. With that, Thank you for watching and have an amazing day.